Hey everybody, it's about time I put another video out for the channel here. So here we are. It's been probably 2 months since I did a video, maybe less, but either way, it's time for a new one. So what we're going to be looking at today is the topic of PVC expansion joints. And maybe you've seen these, maybe you've not have seen these, but it is a good topic to cover. It's a very small section in the Canadian Electrical Code Book. More specifically, the rule that we're going to be looking at is Rule 12, so Section 12, Rule 1118. Alright, so not sure how many of you have installed rigid PVC conduit in your electrical career. I'm sure many of you have. It's a very common task that you do as an electrician, right? But I guess how many people have installed expansion joints in their PVC run, in their installation? Maybe another question would be, how many people even know what they are, right? So what is a PVC expansion joint? What do they look like? Right? Well, I got a little picture here. Maybe you've seen these, right? So this device here, and we got 1, 2, 3, 4 of them in here. Looks like they're on 2-inch conduit. You can Google image these. There you can find a whole whack of images on Google. That's where this one came from. But this section right here in this PVC installation, this is called an expansion joint. And the whole purpose of that is exactly for that, to allow expansion of the PVC conduit installation. Right? So it's hard to tell from this picture, but this is actually a 2-piece adapter or fitting that you glue onto your PVC. And this 2-piece here, you got the outer housing, and then you have this inner piece here. This inner piece actually slides in and out of this outer housing, and there's a rubber seal in here that you cannot see. Not this black line here, that's marker that they would have wrote on there. But inside, further inside, there is a black rubber gasket, and that's used to keep any moisture out of this conduit or this raceway system. But yeah, it's a 2-piece. You could actually take these right apart. It's a 2-piece system, and it allows movement, right? Because we all know that when you heat a material up or we cool it off, it either expands if it's getting hot or it contracts if it's getting cold. Right? So that allows for that slight movement on a PVC installation. Okay, I'm not sure if anybody has seen, it's actually hard to find images, and I thought I had one from my own stash of pictures. But has anybody ever seen walking around, because you know we're electricians and we're always looking at installations, right? Perhaps you've been walking around and you've seen on the side of a building, right? Maybe there's a junction box here, and maybe there's a light over here, some kind of light. And let me thin this up a bit, and I'll just pick a different color for the PVC. Let's actually use gray. And there's a PVC run, and it looks like this. It looks like your mom's freaking spaghetti, right? It starts to droop. Everywhere there's a strap, it's still held up high, but everywhere else it's drooping down, right? The sun's beating on it, it's getting saggy, right? That's more likely because, well, there's 2 reasons why, right? And I'm getting a little ahead of myself, but the 2 reasons would be, okay, so why does it droop? Right? Why does this droop? Or sag, whatever you want to call it, right? Well, the first reason could be is the straps. These straps here, too tight. They've installed the straps too tight, right? If you look at a PVC strap, they're actually designed to not fully encircle or encase the PVC, because this does expand and contract quite easily, right? So if you're putting these straps down too tight, this has no way to move. No way to move. It's all trapped in between the straps. So you should not be over tightening the PVC straps. There should be some play between the conduit and the PVC straps, right? So One reason is the straps are too tight. And we're talking about the straps here. What we're going to talk about, which is number 2, the second reason, and more likely the reason if this is a really long run, is no expansion joints. All right, that's the big one there. But between the two, because even if you had an expansion joint installed on this PVC run, if you got your PVC straps too tight, you might as well not even put an expansion joint in there, because it's just gonna sag. It's gonna, you know, crush into itself and just slowly look like mom's spaghetti, all sloppy and wet, right? Doesn't look good. That's an installation. You don't want to be going around saying, hey, look at that installation I did, right? You want this nice and straight. Right? So I said we're going to talk about the rules for that. So let's look at the rule, right? So that's the PVC expansion joint, and they come anywhere from 1/2-inch PVC, and I'm sure they can go up to 6-inch, maybe bigger. You'd have to go to Scepter's webpage catalog and see what sizes are available, but definitely between 1/2-inch and 2-inch you can get these, right? And they're really not that expensive. They're not expensive, so why not just put them in there? Let's look at the rule. Okay, so this is out of the code book, Canadian Electrical Code, latest edition, 2021. So it's actually going to be replaced within the next couple months with the new edition. All right, so 12, 11, 18, this rule is blended in with the topic of PVC conduit, because when you go through section 12 and you're looking at raceways, there are, you'll see expansion joints for different types of raceway. We're going to zone in on PVC, right? But you can get expansion joints for EMT, that's a different topic, okay? But related to PVC, the rule says, unless the conduit is grouted in concrete, at least one expansion joint shall be installed in any conduit run where the expansion of the conduit due to maximum probable temperature change during and after installation will exceed 45 millimeters. All right, so about 4.5 centimeters. Okay, so obviously here, if it's in concrete, obviously we don't need it. It's in concrete. Where is it going to go? Right? It ain't going anywhere. This is talking about you're installing PVC. It's running along the side of a wall. You're just strapping it to the side of a brick wall or siding or something like that, right? Not embedded in concrete. Okay? So you got to have at least one expansion joint in any conduit run where the expansion of the conduit due to maximum probable temperature change, right? So it's based on a temperature change, and we got to stress this during your installation and even after. So for example, if you're installing this PVC on a nice, you know, summer day and it's only 20 degrees out, but like here where I live, you know, it could get down to, you know, -10, -15 degrees C. Well, you know that, you know, that's going to happen in 6 months. So you have to factor that in. Or you're installing this in -15 degrees C weather, and you know in the summertime you're going to be pushing 30 degrees, right? So this is for during the installation and after. And our magic number here is we need one expansion joint if we're going to exceed 45 millimeters. I just like to say 45 millimeters and up, right? Because what's that mean, exceed 45? Like 45.1 mil? 46 mil? Who knows? For me, I just say for every 45 millimeters of expansion, I want one expansion joint. Okay? So notice there's an Appendix B, and I always tell my students, and I'm telling you guys, whenever you see that, go look what it is. Go look it up, right? When you click in there, you start browsing around in Appendix B, you'll find this table B12-2. And it's a coefficient of linear expansion. It is based on millimeters per meter per degree Celsius. And we got different types of material. You got wood, you got brick, steel conduit, so that would fall under your EMT. You got rigid RE conduit. I personally do not know what that is. Concrete. You got aluminum conduit, right? So think of rigid aluminum conduit. Aluminum conduit, right? And then what we're going to do, for example, is, PVC conduit, because this is very common, right? We're always running PVC conduit on the side of buildings, outside, right? We come up from underground, we go along the building, we go between junction box, maybe we go from a junction box to a wall mount light fixture, right? So we're going to look at PVC conduit. So we got different types of material, and then we have the coefficient value, right? And again, we're going to keep this in our minds. 0.520, right? So I got a sample question here, right? And I got a question down here, I guess. So why do we need them? Well, we need these so we don't have that sagging. So to prevent sagging, we'll say. Sagging, is that how you spell it? That's how I spell it today, right? We want our conduit, so if we got a box, and then like in our example up there, we got some kind of light, we want this nice and straight. So say we got a PVC expansion joint in here, nice and straight, and we still got our PVC straps, but they're not done up so tight that it makes this useless, right? Okay, so let's just do an example calculation. So I wrote up what would be the change in length for a PVC installation. And the PVC we're talking about is just rigid PVC, because there's DB2 ducting, but that goes underground. So you're not going to have expansion anyways. This is for PVC, rigid PVC that you typically install on the surface of a building. Okay. Our installation is 35 meters long. Okay. So you need to know how long the installation is. You also need to know the temperature range that you could see. And what I'm saying is the temperature range for this installation that we could see is going to be anywhere from minus 25 degrees Celsius to plus 28 degrees Celsius. So what would be the change in length for a PVC installation under this? Okay, let me change the color here. Let's go green. Okay, so we're just going to plug in numbers, and then you're going to be like, well, where's this formula coming from? I'll show you after we do this. Okay, I'm going to show you something really neat. Basically, the formula is the length in meters. Okay, the length of your installation, ours is 35, times the range in temperature. Actually, let me put temperature range. Oops. Times temperature range times your coefficient. So let me see if I spell this right, 2 F's times the coefficient. Okay, this is basically the formula that you would use. So all you need to know is the length, your temperature range for that installation, right? What's the temperature range going to be during the installation and after, right? And times the coefficient, which we got from B12-2. So now we just plug the numbers in. So our length is 35 meters times, now we're just looking for a range. So 25, and what we do here is we add. So we take our two temperatures and just add. And we're not going minus 25, we're just taking 25 plus 28. We're looking for a range. Times our coefficient, which we got from here, which happens to be 0.0520. You plug all these numbers in, and you will get 96.46 millimeters. Okay? So this installation, this 35 meter long PVC conduit, and notice I didn't put the size of conduit. It doesn't matter if it's a 1/2 inch, 2 inch, 3/4, right? or if we want to talk metric, 16 mil, 53 mil. Right? We're still confused up here in Canada. One way we're talking imperial, the next we're talking metric. I guess we're just that more diverse. Anyways, it doesn't matter what size PVC we're using. All we need to know is the length and our temperature range and our coefficient. In our case, PVC coefficient is 0.0520. So this is going to actually expand and contract by 96 millimeters, right? So that's quite a bit. That's quite a change. And I have seen PVC conduits being ripped out of meter bases, pushed through junction boxes because they expand so much. It doesn't take much. Okay. And I'm going to touch on something else after we finish this calculation. Okay. Because there is also a point where you would use it even when the conduit's in the ground, and I'll explain that in a second. Right. And obviously in the ground we're not really worried about a temperature range, but I'll show you what I mean in a few moments here. Okay, so my next question is, okay, cool. How many expansion joints would be required for this installation? Well, if you go back to the code rule, basically says where it will exceed 45 millimeters. Now, if my logic, I just start right at 45. I'm not going to go 45.1 or 46. I just say for every 45, I need an expansion joint. And you know you're going to be covered, right? That's, you know, if you want to go by 45.1 saying it has to exceed, you're just cutting hairs. You know, that's up to you and your inspector, right? But I just go by the logic of every 45. Okay? So I know that I'm going to have 96.46 millimeters of movement. If I need one expansion joint for every 45, then how many do I need? I just take my calculation here, and I'm going to divide that by 45 millimeter. Right? And when I do that, I will get 2.1. Now, we're really going to be splitting hairs here, right? Because the question is going to be, okay, do we need 2 expansion joints, or do we need 3 because we're 0.1 over? I'm kind of a play it safe kind of guy for stuff like this. I just round up for the price of it. You know what? I'm just going to say that's going to equal 3 expansion joints. Okay? Could we get away with 2? I'm going to say probably. Right? Is the inspector going to say, no, you need 3 because you're 0.1 mil over? Probably not. But again, you know definitely you're not going to get a defect on this if you go more or if you exceed the code. All right, so for this question, for that 35 meter run with that much temperature range with PVC, I would need 3 expansion joints. Okay? And I guess you should ask, like you could ask, well, where do I find the temperature range? Well, I know my climate, and the easiest way to do it is if you just go to like the weather network or wherever you get your weather, find the historical average of your temperature range over a 1-year cycle and get your lowest and then get your highest. And there's your temperature range that you can go by. All right. Okay, so this is based on the side of a wall. And I mentioned, okay, well, what if you know, it's buried? Like I said I could see stuff. I've seen boxes pulled off the wall. I've seen meter bases pulled off the wall. All right. So say I have a meter base here, and maybe my panel is somewhere over here in a garage. Doesn't matter really where. You'll see in a second here. This is my load center. Okay, let's just call this my load center breaker panel. Okay, these are my breakers. Either way, and here's my meter base. All right, so it's in PVC. There's my TA. Let's say I got brown here. Let's see, do I got a brown? I don't know if it will show up. We'll use gold. Let's say this is my dirt. I know the panel's low. That's a different topic. Let's say this is dirt. And I actually ran my PVC as one solid piece from the meter base to my breaker panel. Okay? Say it was one solid piece. Well, for those that know, in the winter, all right, if you experience cold enough winter, you get frost in the ground, right? So it gets all frosty in here and gets hard, rock hard, right? And during a freezing and thawing cycle, the ground actually can heave and move. The ground actually can move, right? So you think about this. If you did not use an expansion joint in this PVC run that is complete from point A to point B, you literally could rip this from the box. Well, this would be in the house. More likely it's going to happen at the meter base. You literally could pull this out of the meter base, having exposed conductors, or it could heave up into the meter base, pushing up on the meter base, even bending it. I've seen it where the bottom of the meter base is bent up because there's no expansion joints in a complete PVC run, and the ground has heaved, right? It's moved up and down a couple inches, right? So even though the underground portion here is, you know, it's secured, it's almost like it is in grout, it is a good idea when you have a complete conduit system to put expansion joints, you know, at least at the meter base, so that when this ground does, you know, shift up and down during its thaw freeze cycle, you got some movement in the pipe where you're not ripping the meter base out the wall or pulling the conduit out of the meter base, or vice versa. The pipe is shoving up into the meter base, bending the heck out of it, maybe pushing right through the knockout, right? So it's also a good idea to put one there when it's a complete system. You're going above ground, underground, and then back out. If it's just a PVC that is just used for mechanical protection because you got direct buried wire, well then obviously you wouldn't need an expansion joint. So I hope that makes sense. Okay, we'll get back to this here in a second. Back to the formula. What's nice about the Canadian Electrical Code is in the Appendix B you find a lot of examples. So they actually give you an example right in the code book on how you do this calculation, which is located right under this B12.2, I believe. So in their example that they give, they're saying the change in length of millimeters of a run of rigid PVC conduit due to the maximum expected variation in temperature, again, before and after installation, is found by multiplying the length of the run in meters by the maximum expected temperature change. Again, if you don't know, go to look up some historical data, something, right, in degrees Celsius, and by the coefficient of linear expansion, which comes from B12-2. So they give an example of 20-meter run, and the expected temperature is minus 40 degrees. I don't want to live where that's at. That's too cold for me. And the maximum is 30 degrees. So they're saying the change in length in this example would be 20 meters. So again, here is your, let me change your color, your length. There's your length. Here is your temperature range, so the 40, which came from the minus 40, plus the 30. So there's your temp range. And then here's your coefficient right here from B12. B12.2 or dash 2. Right? Plug those numbers in. This installation is going to change length by 73 millimeters. So in this case, you know, how many expansion joints would I need? Again, I just like to take 45 as my base number. So I'd go 73 divided by 45. Let me calculate that here. Let's see what we get. 73 divided by 45. Well, you get 1.6. So this one, I'm going to say you need 2 expansion joints. Okay, so they give you an example even in the code book, which is nice. Appendix B in that Canadian Electrical Code and the Ontario Electrical Code is great. There's so many examples. Okay, all right, so this is what they are. This is what happens when you don't use them. Went over the rule, the table, did an example. Talked about another example where you want to use one, and that is a complete PVC run, right? When you got your underground coming up to the enclosures. Right? The ground will shift. Now, how do we install this stuff? How do you install a PVC expansion joint? Not hard at all. We glue them. We glue them on, right? So here in the middle is our expansion joint. So there's our expansion joint. And again, when you buy them, you buy them based on the size of conduit you're running. So if this was a 2-inch or a 53 millimeter, that's an ugly 53 millimeter conduit, well, that's the size of expansion joint you would buy. You'd buy a 2-inch, 53 millimeter. When I go to the supplier, I still talk in imperial, right? It'd just be weird to go there and say, give me 100 feet of 53 millimeter conduit, right? Just let's pick one. Just the code book's all done in metric. Okay. Now I don't usually put a strap on the bigger part personally. They're showing that here. You definitely don't want to put a strap on either or, because you're probably going to prevent it from moving. I personally put them on the PVC run itself, and I leave the expansion joint alone. Right? The whole secret to this though is to make this expansion joint, to give it its ability to do its job. You cannot have these straps so tight that the pipe does not move within it. All right. Again, next time you look at a PVC strap, just kind of put it on a piece of PVC, and you'll see there's actually some play in there. It touches on the top, it kind of holds it a bit on the top, but the sides, there's space, right? So don't be putting your screws in here, your 1-inch 10s, on an angle trying to tighten up the strap around the conduit, right? Because that defeats the purpose. Even if you don't need an expansion joint, you do your calculation, you find you don't need an expansion joint, still, don't do these straps up so tight, because you're going to get the saggy noodle going on. Okay, so it talks about solvent cement or solvent weld. So you got two types over here. Now, before everyone gets all, you can't use that one on the bottom, you are correct. All right, on the top, PVC conduit requires PVC solvent. All right. I hear guys saying just use any old PVC glue, and they'll sit here and use, the plumber's ABS cement. This is for ABS pipe. It's yellow, right? It's on the black pipe for plumbing. We don't use this on PVC. Okay? Don't use ABS on your PVC. No. Okay? When you're doing a PVC installation, you're using PVC glue. Okay? Of course, always read the MSDS, because this stuff reeks, and it's got a lot of nasty stuff in there. All right? A lot of nasty stuff. So you want to be using this in fresh air. Okay, I think that's everything I had to kind of show you about this. I'm going to be dropping another video soon, like almost right after this one. It's going to be on a different topic, though. For those that don't know, I do a lot of controls in PLC as well. So I am a licensed 442-309A master electrician, but I also do a lot of controls. And I'm thinking, I don't want to create another channel. And I'm thinking about putting some controls on this channel, and some programming topics on this channel, and just having categories within the same channel. Now, the problem I'm having with that is the name of the channel has to do with the code book. So I'm curious, would you guys like to see, some different topics on the same channel that honestly go all along with the trade? It does, right? It's just not residential, commercial. Like for me, I'm a heavy industrial guy. I teach a lot of residential. I've done residential, but I'm also really heavy into the controls. So I think I can do a lot of great videos with that. So if I do that and I segregate them into topics, I guess I'm asking you guys, what would be a good title to the channel? Like seasoned electrician? I don't know. I'm open to hearing your suggestions, right? But yeah, watch for a video coming out. I think I'm going to do one on how to convert how to create a simple control diagram, right? Just take a break from the code stuff. But either way, I hope this helps. I hope you guys are using expansion joints, or at least doing a calculation to see if you need it. It's not hard, very easy to do. And again, make sure you're not over tightening your straps, because if you do, it's pointless. You're going to get the saggy noodle anyways. Okay, so Rule 12, 11, 18. Hope you liked it. Leave your comments. I do reply. Sometimes it takes a few weeks, but I do check on them, and I do try to reply to everybody. If you have any more suggestions for this channel, I like to hear it, because I like to get more videos going. I like to hear, maybe some topic ideas from you guys. All right. So until next time, be safe.